So this is the last session for the day. Hope you have some energy left because we'll have a Q&A soon as well. So first of all, thank you Angelo, Geoff, Yadu and Sunil for coming to the panel. The fireside chat, so we'll just keep it a bit informal. I have a couple of questions for each one of you and then we'll open up for the audience. So yeah, we can quickly start. So it's a common question for all of you. What is one feature of ROS or one package of ROS that you really like and you would want everyone to use that? And what is one feature of ROS which is missing, which you think should be there in the future? So, Angelo, you can start.
So I will start with the feature that we like in the future, and I guess that can be guessed. It's first-class support for Rust programming language.
Okay.
We'll get there. We'll get there.
Yeah, we'll get there, but
we're making progress.
At least that's my wish.
Yeah.
Because the language is growing in terms of adoption. I think will be good for users, will be good for the stack, and that's the language I get to use most. So I think would be great. So that's in terms of the feature that I like the best, that I would like to have the best. Then in terms of the feature that we use the most, okay? So maybe I'll slightly twist your question. The feature we use the most, obviously, is RMW, right? So we know the ins and the out, that's the things we get the closest. And I would say the second one that we have experimented the most and we tend to have fun with is navigation.
Okay.
I think that probably the package I think is the most cool package in ROS would be Plot Juggler. And this is, it's an awesome tool.
A lot of love.
Made by one guy who just saw a need and thought, hey, I can try and make that. And he made it, and it was awesome, and everyone uses it, and it just keeps getting better. He's up to version 4 now, but just like every time he makes a release, it's awesome new features. I think something everyone should be using, because this is just, it solves so many problems when you're trying to debug your robots.
And nice memes too.
Yeah, that too. Yeah. The feature I think I really want to see is better support for on-system orchestration. So orchestration of bringing up your system, bringing up your nodes, turning them on and off as needed, taking them down again in the right order. Things like that would enable a lot more dynamic robotics. Okay. Currently, ROS systems tend to be quite static, which I think is disappointing because they don't have to be. Yeah. You know, the underlying middlewares, Zenoh and DDS, can support dynamic systems, but we don't really take advantage of that. I'd like to see more of that.
Yeah, sure. So, Yadu.
Yeah, for me, it would have to be ROS composition or ROS2 composition. So I realize it's a feature that not many developers know about. So the whole point of ROS is instead of writing one giant monolithic program that does all your robot behavior, you split the behaviors into small nodes that each does, one particular functionality. This is great for R&D and development, but when you want to run in production systems, you want all of these nodes to run in the same process, and this is what composition achieves. And the overhead to do this is almost non-existent. You have a package, an immense CMake package. You just have to add a couple lines to your CMake lists. And all of a sudden at runtime, you can choose to compose all these different nodes into the same process. And the advantage here is that you reduce your CPU and memory footprint for your overall process. So when you're running on edge devices, you're going to see some savings in CPU and memory consumption. And you also have the option to turn on intra-process communication, which basically short-circuits the middleware completely. Angelo's going to hit me for saying this, but
that's good. I mean, you should use it. You should use it when you need it. Right?
Yeah, exactly.
Yeah.
Exactly. So when everything's running in the same process, in the same host, you don't need a publisher and subscription. You don't need the message to go through RMW, serialize, go over the wire, deserialize, get it on the other side. So when you compose everything, run it in the same process. When you receive something on the subscription side, you're just getting the pointer location. There's no copy happening. It can be zero copy if it's one publisher, one subscriber. But this is some really nice tips and tricks you can use and some great features of ROS2 that compel you to switch, in my opinion. That's one thing that I really like. What could be improved for me would be making this sort of stuff easier out of the box. As I mentioned now, you have to go tweak CMake lists. You have to make a few changes here and there. But if ROS can get intelligent enough to figure out what's the best way to transport this data on its own, whether it's sharing pointers or sending it over the middleware, that could provide a much better out-of-the-box experience for everyone.
Okay. Yeah. Sunil?
Okay, so ROS 2 was ROS 1 to ROS 2 was a great leap forward. ROS 2 is mainly suited for all the industrial, commercial products. I'm really biased over here, but Isaac Ross is my favorite one. Okay. But apart from that, I am looking forward to what we can improve. So really, we are talking about amalgamation of robotics and AI and ML, right? While all the developers knows that we are talking about a great combination of great two technologies. But currently, whatever framework support is provided from the ML or deep learning side is really hack and hope kind of a support. I would really quote Triton Inference Server as well into that bucket as we really require a good plug and play support for ROS, where you'll not have to rely on hope, but you certainly know that it is going to work out. It is not going to just work out in your laboratory; it is going to work out in the field as well, and it will be stable integration, right? So that really is something that I would like to improve.
Okay. Yeah. Thank you. I should have asked Angelo and you apart from the things that your companies do, tell us one package.
I told you. I told Nav. We don't
Yeah,
do
you
Nav,
said
right?
that.
Yeah.
Okay. Anyways, yeah. So the next question to Angelo. What advancements are you working on Zenoh to make it real time and low latency? We already saw all the capabilities, but
Yeah, so in terms of, so there is already support for real time in Zenoh. And I think the point is now, how do we expose that in ROS, right? And so already I believe from 1.04 that we just released, there is a way in which you can map Zenoh priorities to key expression, okay? So in Zenoh, we have 7 priorities. You can use those programmatically when you do an operation put that I was showing today, you put with priority, whatever, right? And now, so you don't have access to that in the RMW, but us, we want to make sure that if you're sending, LiDAR images and then a command, if the command is high priority, overtakes the large image, you will be able to do that by configuration, deciding which priority maps to which set of key expression, okay? And more importantly, you will also be able to decide how that maps to networking resources. Because again, you saw that we were running everything out of a socket. That works most of the time. As if you spotted today in my slide at 300 kilometers per hour, we do automatic fragmentation. And our fragment have a predefined size, by default 8 bytes, which limits the head-of-line blocking in case of something needing to overtake. But if you want to further reduce that head-of-line blocking, you can associate a separate link to every single priority or to a set of priority. It becomes a trade-off between resources versus how much priority inversion you can tolerate. So this is something that the RMW Zenoh will benefit just by configuration, which I think is great. And then there are few other important things we're working on concerning video, okay? That's one of those. We have done some experiment. I was showing some of the result actually in Odense. And something more will be coming out, along with some further optimization for Wi-Fi that I can't disclose yet, okay?
Okay,
Voilà.
interesting. We look forward to
so
that.
So it will be a big surprise, but
Yes.
yeah. So I think the video will come with 1.1, which is planned for the 12th, so 1.1 or 1.1.1, so either 12th of December or early January, because
Nice.
then,
Yeah, we'll be looking forward to it for sure.
And for the Wi-Fi, I will post, so stay tuned because I will post some result when I'm back, because I was doing some experiment before leaving, which are very promising, and so you will get a hint of what more we'll do.
Okay. So, Geoff, how do you see ROS2 evolving in the next 5-10 years for supporting more complex robotic systems? And how can the community help or get involved in that?
I think that ROS itself, to get better support for more complex and larger robotic systems, I think that the biggest step has already been taken, which is RMW Zenoh. That is going to enable us to move beyond just very small networks and very small networks of robots to whole systems that are connected across even the internet. I think if you've seen the ZettaScale podcast a while ago, with Yadunund in Los Angeles and Julien in Paris, and they were controlling a robot over the internet using Zenoh. That sort of thing, that extrapolates way up to massive networks of robots. And so that is going to enable a lot of growth in that area, and that is really the most important step, I think, for that. But building on that, we need a way to control all these robots and manage them. We can't just sort of chuck them all out there and have them all do their own thing. We've already learned that doesn't work. And particularly, I think we'll see that this is going to be a lot more heterogeneous. We're not just going to see, say, Toyota robots used everywhere and no one else's. We're going to see every company's robots used together in the same places. A city full of robots from all these companies, or a country full of robots from all these companies. And so that was where I think OpenRMF is really going to be a major game changer, because what it already enables, and through further developments is going to enable even more as it becomes capable of supporting bigger and bigger fleets of robots and fleets of robots. It's going to enable us to have much greater coordination of all these robots that are all working together in society, out on the streets, inside buildings, in office buildings, all these things, and working with the machinery that we have in our environment, things like elevators and automatic doors are the obvious ones, but also charging points and places to pick up and drop off stuff and delivering parcels and all that sort of stuff. OpenRMF is able to coordinate all of that stuff. And I think that because it doesn't rely on any one particular brand of robot or model of robot, I think that OpenRMF and ROS together are going to enable huge fleets of robots across massive spaces, which I think is going to be really exciting to see.
Okay. And how can the community...
Well, I think the best thing to do is to start using OpenRMF and start trying to build these big fleets of robots and understand how OpenRMF can work to make them work together, and where it can't, contribute that, implement it and help everyone else build it together. And Yadu said that there is upcoming plans to be able to scale the fleets way up and way down and into very tight spaces and very wide spaces. Get involved in that work. Help us build it, because it's far better that all these people build it together than a few people build it in one little group, because then it will happen so much faster and it will also meet everyone's use cases so much better.
Yeah. Okay, thank you. So, Yadu, does the Intrinsic platform address any gaps in the ROS ecosystem, and which can improve the adoption of ROS in the industry?
Yeah, so the ROS SDK provides a great out-of-the-box experience for users to go from ideas to prototypes. But what's missing really is that journey from a working proof of concept to deployment in a production facility. You have your nodes, you have your workspace running. How can I deploy this somewhere? How can I manage updates, security patches, all of these things? And to me, this is the problem that the Intrinsic platform tries to address. So it's basically infrastructure which runs robotic capabilities. And recently at ROSCON in Odense, we unveiled this collaboration where we can take ROS nodes as it is and run it alongside flow state applications. So what this provides developers is two things. One is you're able to get your ROS nodes out into production environments where people can actually use it. And you as a developer can work on updates and then rely on the platform to send these updates over the air. Could be patch updates, security bug fixes, anything, right? And for consumers, it really opens up the world of ROS to a lot of people. Right now, the barrier is quite high to start working with ROS, as we discussed earlier. You need a Linux environment, you need some familiarity with tools, etc. But I just want to use a ROS capability to solve my needs. And if someone can distribute ROS capabilities through the Intrinsic platform, I'm able to use those capabilities without knowing too many details of the environment, the operating system, how it was compiled, etc. So to me, this is a big problem that the Intrinsic platform hopes to solve, like really democratizing access to these powerful capabilities from the ROS ecosystem to really everyone.
Okay, thank you. So, Sunil, this is a bit off-topic question regarding AI. So, With AI playing an increasingly critical role, how is NVIDIA addressing the ethical concerns and ensuring the safety of AI-powered robotic systems?
Yeah, I would really say a big question. Uh, okay, so often we see that ethical concern and safety are intertwined, always related, right? So when you let loose your robot in the wild, there are many concerns that you need to address. So first one could be your operational concern, like let's say you've designed a robot which works great in your laboratory environment, a floor cleaning robot, right? But when you let it loose in the wild, when you let it loose in the real environment, you need to count for what else that can go wrong. So there could be a slippery floor, so where you need to simulate the physics. There could be a notorious cat. There could be a baby crawling toward it, or maybe we are moving towards the robot while texting, or walking while texting, texting while walking. That anything can happen, right? So first one is the functional safety, and at NVIDIA we have designed a realistic physics simulator. We have made sure that it's built into Isaac Sim, and it is already covered in Omniverse, which provides a bigger umbrella for importing your models from various platforms. So Isaac Sim really provides that environment so that you can simulate the best, and thereby your robot can work the best when they're actually tested in a real environment. So that's related to the functional safety. The second one is physical safety. So safety to your IP. Nobody is going to touch your code. So when that comes into picture, all our hardwares are having a secure boot. Hardware isolation is there. We also comply to ISO 26262 standards. And that really makes your IP safer. Nobody is going to touch your IP. Nobody is going to tinker around what code you have written, and ensure that whatever you have put in that particular box is really getting delivered to your customers. The third thing that I would really go is really related to ethical concerns, like whose data you are using. So typically the first problem that comes to a developer is like, I want to design this robot, but where's the data? And that's where Isaac replicator comes into picture. You can synthesize your data in a physics-like realistic environment. And once you synthesize your data, it's your property, it's your IP, you are building a model out of it, you are creating a product out of it. And there are safety and ethics related concerns are also really, you're addressing over there itself. So these three things that we are taking into consideration, and we are making sure that we provide more and more features to these three essential steps: functional safety, physical safety, and the data. And thereby we make sure that products are developed ethically, delivered ethically, are safe for the environment.
Okay, thank you. So now we can open up for the questions. So yeah, can we have some mics?
Yeah, I'm audible. Yeah. So this question is for Angelo and Geoffrey. I mean, we know that Rust is better at memory handling, or you have to be more careful while memory handling when you're writing code in Rust. But this push that is happening towards Rust, not just in ROS, but in other open source software as well, is it, kind of driven by the FBI's or the US government's push towards dropping C++ as a programming language because of its memory safety issues, or are there genuine performance improvements with Rust over C++?
So maybe I take, so first of all, when we started using Rust, the first time we evaluated Rust as a company was in 2015, and we discarded it. Because back then, it wasn't really ready for production in our perspective, okay? And the problem was mostly with the ownership checker and the lifetime checker, which was just a huge pain, okay? We reassessed it in 2017 when 2018 edition was about to get out. And then we said, okay, it's fine. So that's time-wise. So that tells you that it was long before the announcement from the NSA, because it was the National Security Agency, and DARPA, which dates 2-3 years ago, when they made essentially this call to all the American system integrator to move not necessarily to Rust, but to memory-safe programming languages. And then we'll get why Rust is interesting and appealing for system programming as a memory-safe programming language. The reason why we were looking for a programming language like Rust is that we build networking software, right? And it was already well known, well before DARPA or NSA woke up and told to the world that 70% of the security bugs come from memory mismanagement, okay? So that's well known. And this is why the very first version of Zenoh was written in a programming language, so let's see how many of you know or have used it, OCaml.
Yo.
Yeah, you're a functional programming, yeah. So few people know it, but it's a programming language that besides being high level, it's very secure because of its memory safety and overall its type system. And it's a gorgeous programming language. It's gorgeous.
The only one that's not as good at is Erlang. Erlang's better.
Perspectives. Okay. And so when we moved away from OCaml because the show ended, you see, essentially some of our users were saying, hey guys, I mean, where do I find OCaml programmers? I said, in France. Well, you find them also in Yale and Oxford, but there aren't so many, okay? And if you find them, they are very expensive typically. And so we didn't want to give up the safety. We didn't want to give up the abstraction. Because recall, our job as engineer is to build composable abstractions, right? It's not just to code programs, right? The first goal is to build abstraction that are nice to compose. And a programming language has to support that job. For me, a programming language is as good as it makes it easy for me to build abstraction that become first-class citizen of the domain problem that I'm trying to solve. And so to that respect, some programming languages are very poor, others are quite good. So one was abstraction. The second one was runtime overhead. We didn't want to have a tracing garbage collector. And again, I say tracing garbage collector because even reference counting technically is garbage collection. But I don't want to open a big parenthesis on that. Okay, tracing garbage collection is what, let's say, Java has or what Go has, okay? Why? Because it introduces some undeterminism in your computation. Unless you have a real-time garbage collector, but that still limits the level of real-time you can do. Now, our experience in Rust, and so we adopted much earlier than many other companies. We adopted async very early. And again, we went through all the pain of this earth, right? Because we were on the bleeding edge. And for those of you that have used async programming in the early days, I mean, wasn't always a path of joy. But for us, we do networking software. The ability of doing asynchronous programming in high performance, I mean, was very powerful. And I think today, in retrospect, after 7 years of Rust, we are very productive. We still have some portion. Well, one of our implementation in Zenoh for the microcontroller is in C. And we see a 2x difference in productivity between Rust and C, okay? The other myth, and maybe I'll stop because I'm taking too much time, but the other things I want to say, there is another myth which is, it's super hard to get started with Rust. And I mean, we weren't a Rust shop. Many of us did OCaml, many of us did Haskell in the past, lots of C++. But the key is to have a core of people that know Rust, and then new people can get it real quickly. And you'll discover something else. At some point, someone will come at you saying, Rust sucks, I cannot do that. And you look at him. You just got, learn something also about C++, because this is something you don't want to do in C++. And I'll pause there.
Okay, thank you. So,
Geoff,
any comments?
I think you've covered most of it. I do want to say, though, that Rust has been around since 2003.
Yeah.
It is not that new. Obviously, it's made a lot of progress in that time. But this whole thing with recent push by governments to use it is, it's come after a long time of gestation of Rust. And on top of that, all the energy going into Rust and the drive to adopt it for memory safety and security, that started years before the NSA came along and said you should use it.
Yeah.
So it's yes, the NSA has said people should use languages like Rust, but there are very good reasons why they said that, and everyone already knew them anyway. So it's just they basically rubber stamped what we already knew.
Exactly. Good point. Yeah.
Yeah.
Okay.
Next question.
Next question.
Hello. My question is to Sunil. Hi. The work you're doing on NVIDIA Isaac Sim is really very much fascinating. Just my question is, any plan on giving a better support on GPUs? Like currently, the basic requirement of your GPUs is around 16 GBs for a medium range. Or any plans on supporting it on gaming GPUs of NVIDIA's?
Okay, I think it's already supported on gaming GPUs. It just require RTX.
Okay.
It could be anything. Your laptop GPU with a ray tracing core, it is supported. And as far as the memory requirement goes, it depends on model that you are really simulating with, right? It works on a laptop, it works on a workstation. It just require RT cores.
Yeah, I mean the GPU requirements is quite high. That's the one thing. Like any plans on reducing the GPU requirements or giving a better support of some cloud platforms?
Yes, yes. So we have received this, complaint from many of our users. We are working on something called optimizers. So provided that you have built a scene, now build has, let's say, millions of triangles into it. Now, how we can optimize and reduce those number of triangles and still provide you a better, high definition, photorealistic physics, high definition physics into it. So we are working towards the same. That will be available very soon. I cannot comment on the timelines of the same, but yes, we are working on the same. So that will reduce the overall size of the scene that you are working with and still will provide you the same class of physics, better support, less memory requirement.
Thank you.
So this is a slightly long question, but this is mostly about the licensing of Open Robotics. So ROS has been open under the BSD license for a long time. And the thing about that is, especially since it goes from being a hobbyist project / ecosystem, there's much more industrial adoption now and a lot more abstractions as was shown in the last 2 days. The thing I'm worried about is as companies like NVIDIA, for example, adopt it into much more abstract like pipelines that require ROS at the very base level but have a lot more proprietary elements to them. Do you think it will threaten the contributions? You've recently moved away from the benevolent dictator model, but as controversial as that might be, with the recent WordPress debacle, it at least tries to ensure that there are enough contributions coming back to the standard. Do you think with the current industrialization of the language, you'll be able to sustain the open nature of ROS and ensure continuous contributions to it?
Yeah, I think we will. First, a quick correction. ROS 1 is under BSD, but ROS 2 is under the Apache 2 license, which has important differences. Broadly, they are the same, but Apache 2 provides more protections for patents. I think that, from our point of view, seeing things like what Intrinsic is doing, where they're building ROS support into their proprietary tool chains, that is good, because that shows that they believe ROS is a solid foundation for a commercial tool that they want to sell for money, which means they're going to support it. And they don't just take ROS and plug it into their tool and have it work. They find places where it doesn't quite match and they want to improve things in ROS, or they find bugs that they want to fix to make sure that their software that they're supplying to their customers is going to work. And so all these places that are using ROS in commercial tools and abstractions, they are supporting everyone by giving back and fixing those bugs, adding those features, making those changes. So while, yes, it looks like they're building something commercial on top of ROS and they're not contributing back, they are actually contributing a lot back. And even if we don't get concrete source contributions, just the fact that they build something on top of ROS is good for ROS in the community because it gives everyone else confidence to use ROS. And that's very important.
Sir, I have a question. What are the some of major challenges that the ROS community faces as it grows? And what opportunities can be leveraged to overcome them? Or what can the community can do to support the efforts that you are taking forward?
Well, in terms of challenges, I think that the biggest one is that as robotics grows, it's going to continue to become a more complex field, and there's going to be an increasing amount of software packages out there built on ROS that people can use to build robots. But finding those packages and understanding how to use them and put them together, the more packages there are, the harder that is. And so I think that is something that will continue to be a problem unless we find good ways to address it. We do have tools in place to help people find packages and find the documentation for those packages, but people need to use these tools, and people need to particularly provide the input for these tools. So if you make a package or someone else makes a package, they need to make sure it's registered at index.ros.org, which is the canonical list of ROS packages. And they need to make sure that their package has documentation, and that the documentation is in the correct format, so that index.ros.org will pick it up and automatically generate a documentation web page for that package. And things like that are very important. And then we also need to see a lot more community education efforts. And by that, I don't mean like going to a school and teaching ROS. I mean making YouTube videos, making blog posts, for example. Here's how I made a robot. I used these packages. Here's how I plugged them together. These are the problems I faced. Here's how I overcame those problems. Because if you look into the makerspace, the community of people making things with 3D printers and electronics and so on, this is how they all learn. And there's just explosion of amount of stuff that's in that space over the past 10, 15 years. And there's so many different ways to do everything. So many different electronic parts you can buy and then plug together and program in so many different ways. And they all learn from each other through YouTube videos and blog posts and posts on forums and on Discord. And that's what we need. We need to see everyone teaching everyone. And I think that's the best way to support everyone being able to understand the growing complexity of robots and being able to learn how to use all the tools that we have available.
Okay. No other questions? Okay, so
So hello everyone. As we know, there has been a lot of focus on like developing, integrating ISAC-SIM, going ahead into robotics and all. But there has been there's still constant development of Gazebo, right? And like newer versions are being developed. And so how do we, as a developer, how can I decide which one would be the best for, should I go for Gazebo, or maybe if I should decide ISAC-SIM would be better. So how can I understand like what exactly should I target when I'm going to decide a simulation environment?
So generally it's like if you just require physics to be taken into consideration, go to Gazebo. If you require physics and realistic rendering requires as a requirement, go to ISAC-SIM. That's something I've seen people taking this decision. And coming to the notebooks and
we're thinking about at an industrial level to develop a product. So which one, I mean, like I would like to know your insight on both the simulation environments at a deeper level.
Both the simulation engines are very similar, okay? Gazebo I'm not much aware of, but when the physics is concerned, both the physics are similar. In the ISAC-SIMs, we are trying to incorporate wide variety of physics support. For example, the next version that we are going to release, that is going to have something like, you can simulate a heat sink which is there in your phone, right? Smallest level of a physics, micro level of a physics simulation to the entire Earth level of a simulation, like you can simulate the entire weather of Earth, right? So we are trying to provide the entire spectrum of physics support into a ISAC. Whereas Gazebo, where it's just focused on robotics and physical things, the physics support will be limited to what is required, right? So that could be the difference. Otherwise, physics engine in both the cases are nearly the same.
I'll add on to this a bit because we have used both. Like in some applications we do use Gazebo, in some applications we do use IsaacSim. So mostly what we try to see is like where do you need customization more? If you need customization, so by customization I mean is if you want to add a new sensor. So right now there is support for a depth camera if you want to add a stereo camera. That is available that can be done much more easily in Gazebo. If you want to add environmental effects, any kind of customization you can do with Gazebo because it gives you the flexibility to change the physics engine. So by default you have ODE, Bullet available, the rendering is by Ogre, but you still have the option, the new Gazebo sim is modular enough that you can even change your rendering engine as well. So if you want customization, then definitely Gazebo is something that you should go for. But if you're sure that this is the things that I need, but I need like photorealism, I need accurate photorealism, I need accurate physics, but I only need to work only in a very narrow scope, then NVIDIA Isaac Sim is much better. So in our experience, like that is what we have observed. Maybe Yadu can comment.
Yeah, I'll just add that there's never going to be one tool that satisfies all requirements. So it's really up to you to do the due diligence to understand what are the trade-offs or the pros and cons of each and find out what best works for your application. But I'm also more interested in being able to write software that's kind of simulator agnostic. I should be able to write my core orchestration logic in a common platform, which could be ROS, and then if I wanted to, I simulate on Isaac Sim. If I wanted to, I simulate on Gazebo. And we see advantages of both as well. In fact, Open Robotics was contracted to build a bridge between USD and SDF, for example, because we see the value in interoperating between Isaac Sim and Gazebo. So yeah, it's a decision that has to be made depending on the use case. I think they're both fantastic.
Yeah, I think I'd like to reiterate the point that Yadu made, which is that these are tools. And as an engineer, you have to evaluate the tools available and choose the best ones for the job you are doing. And so it's like, if you're cutting wood, do you use a circular saw or a jigsaw? You have to decide which one's more appropriate to how you're cutting the wood and why. And it's the same with simulators, same with all the tools we use. And I previously worked at an autonomous driving company. We used 3 simulators at the same time. One of them was very good at doing the graphics for the photorealistic sensor simulation. One of them was extremely simple graphics, but it was very good for testing our planning algorithms. And this is what you use. You use the best tool for each part of the job you're doing. And the advantage of working with ROS and Gazebo and Isaac Sim and all the other simulators that are compatible with ROS is that you can choose the right simulator at the right time. Yeah.
Can I have one last question and then we'll wrap up? Yes.
Hello? Okay. Sorry. So my question is mainly to Sunil sir, but anyone can answer this. It's not more leaning towards ROS here, but as storage is all important to us and respected to organizations also, like storage is a very huge concern. There has been a lot of technologies like state-of-the-art, like optical data storages. And my question mainly leaned towards holographic data storage. Do you have any insights towards that topic?
No, I think I don't.
Wrong conference.
Yes. I
mean, you can answer whatever you want. It's completely fine. It's just that if there is any insights, you can share whatever you know. Like that's completely fine.
Sounds cool. Sounds pretty cool.
Just a question.
We'll love to know more about it.
You can answer whatever you want. Anything is plus point. Anything is plus point for me. Yeah.
I've seen question where people reach out to us saying that Jetson does not provide enough storage and those kind of complaint, but I've not seen any holographic and other storage related issues. So I'm not the one. I'm not the right person to answer this.
I think for the rest of us, it's just the back end.
Yeah, I mean, it sounds cool and it probably looks really cool at night when
Yeah.
it glows, but
Yeah, so my question is for Sunil, sir. NVIDIA Isaac in general has been not focused on underwater robotics or maritime robotics. While Gazebo does has plugins to simulate hydrodynamics, Isaac doesn't have that right now. So is there a plan to incorporate that in future? There have been attempts to use the underlying physics engine in Unreal and Unity, but the Isaac sim doesn't. So are you guys planning to release it soon, or what's going on with that?
That's a very great question. So we tried to simulate how you can basically simulate the molecular environments like air or maybe water or a protein simulation. Everything put together. We have tried to put everything together in Isaac, but we are not yet successful. So we, as you know, Omniverse, Isaac Sim is a sub package of Omniverse, and Omniverse can work with 100 other package or software providers. Some of them are providing you a fluid physics related support, right? So we are currently relying on them. We don't have anything in production that can really substitute them, and we really don't want to go into that game, because Omniverse was made to make sure that it's a collaboration platform, not just an NVIDIA platform. So currently, if you want to simulate anything like fluid dynamics related to air, water, resistance, you will have to rely on third-party packages.
Okay. So I think that's it. So to close this, I would ask quickly the three of you, because you have come a long way. How has your experience been? Just a couple of lines quickly.
it's been
ROS
awesome.
in India have been here for the first time.
Absolutely awesome.
Yeah, it was great.
Yeah.
Fantastic.
Brilliant.
Okay, just one word is enough. Okay. Okay, so then thank you to the whole panel.
Well, and thank you.
For the discussion.
Yeah,
Thanks, everyone.
Thank you, everyone.